We'll be starting the presentation. So if everyone who's currently in the area kind of settle down. All right.
Welcome.
All right, guys. So thank you for coming to United Astronomy Clubs of New Jersey. A couple things to note. We not only do this live in person, April through October, every Saturday at 8 p.m. And that's Eastern time because we're in New Jersey in the U.S. We also broadcast this live on our YouTube. So we do actually, if you ever can't make it here or you're out and bored camping, you can always check us out on our YouTube page. Please check out our website, UACNJ.org. That'll give you all sorts of information about our organization, our member clubs, our coming talks, our past talks. And like I said, since we do broadcast these live to YouTube, we also keep them on YouTube archive. So you can also go back and see our past programs from when we started doing them when the pandemic first hit us. So a couple things to know. I have been asked that if you are in the live audience, please be mindful that we are having a presentation. If you wish to have discussions with other people, please step away from the presentation area so that people can listen in, even with the speaker. Sometimes with the extra chirping of the various crickets and cicadas, it can get a little bit hard to hear over people talking as well. So if you are, like I said, in the live audience and you wish to hold conversations, please do step away from the lecture area. That being said, while I see a couple more people kind of streaming in slowly, we're going to go over some safety things and some not so safety things. If you are here and you need to use the bathroom, we have the porta potty. It has a red light attached to it. It is to my right, your left. We do also have a small gift shop. All the proceeds from any donations made in any of our jugs or the little boxes attached to the observatory or purchases made through the sales desk do go to help keeping our lights on and help us keep offering the free public programs. And we thank you very much because we know everyone has been struggling through the pandemic, and everyone's quite generous donations have allowed us to stay alive, where some nonprofits have not been able to make it. So, that being said, if you notice, it's actually getting darker earlier, which is a great thing for astronomy. It is also slightly dangerous for those walking around. When you go to leave in your car, please, please, please use your headlights. We don't like getting run over. People don't like getting run over in general. Would not actually, there's probably someone who would like it. We're going to assume, for the sake of argument, that no one here likes it. And we're going to avoid that by using our headlights and moving slowly so that we don't accidentally hit people. Right. Oh, someone has a headlight out as I say that. So, with that, over to all the way to our left are various sheds with roll-off roofs. That's where we house each individual telescope, and that is where you would normally, like I said, look through the eyepieces. It looks like we do have some spotted clouds, but we are able to see some various objects. So we might have some telescopes up that have eyepieces. Keep in mind, since the eyepieces are a delicate piece of scientific equipment, the constant sanitation between uses isn't really possible without destroying the eyepieces. So if you are not feeling well, please avoid looking directly through the eyepiece. We also have set up cameras where we would normally put the eyepieces to actually have you be able to look at the image you would be able to see through the telescope on a projector screen. Right. So since it looks like most of you have gotten settled now, and I've stalled long enough, tonight's presentation is What's Up in the September Sky with Lonny Buinis. Lonny has been obsessed with all things outer space since childhood, when he looked through his first telescope and saw a pterodactyl pass over the moon. In the age of mammals, he helped start the United Astronomy Clubs of New Jersey, and in 2016, during the Ice Age, UACNJ dedicated the Lonny Buinis Observatory. Lonny holds degrees from Stevens Institute of Technology in Physics and Computer Science. He is a member of the International Association of Astronomical Artists and created the first interactive space history book. He is as skeptical of experts as you, so after the talk, ask questions. And we will be having a Q&A session after the talk, and I am actually monitoring the online chat. So if you have questions, please hold them to the end. And with that, here we go. Lonny.
Thank you very much, Kim. Oh, thank you all. And thanks to Kim and the dedicated amateur astronomers here who run the UACNJ totally volunteer. So they like it when you ask a lot of questions afterwards. They don't like it when you walk into their tripods. If you want to see an astronomer cry, kick the tripod. Please don't do that. Because they spent a lot of time setting up the telescopes so that they could show you what stuff looks like through them. I've been here a long time. This is 26 or 27 years I've been doing this. Hope to continue doing it. And every once in a while, I know it's impossible to believe, but I actually make mistakes. So I just noticed that for those of you who are confused and think that today is August 7th, it's not. Check your calendars. I can see a lot of people are busy referring to their phones and tablets and computers that they're carrying with them, taking notes on pencil and paper. I know I'm making it up. I don't see anybody doing anything, but if you do want to take notes, you're welcome. So let's get started and find out what's up in the September sky. I got some news first. August 16th, last month, several astronomers, researchers from Brown University in Rhode Island, United States, used a special camera on a giant 4-meter telescope. Now, a meter is bigger than a yard, so 4 meters is 4 times 3.3. Quick, mathematicians in the audience, 4 times 3.3. Again, no pencil, no paper, no tablets.
1,000, or no, yeah.
Round off, it's around 13 feet. Yeah, it's like 13 feet, a 13-foot mirror. It's like the size of this screen, or bigger.
Actually bigger.
Oh,
right.
Much bigger than that.
Much bigger than the screen. Thank you for correcting the speaker. You, get out. Oh, no, I'm kidding. You can correct the speaker, but you know, see this back scratcher? Some people like old-fashioned pointers, and some people like new-fashioned pointers like this one. Take your pick. Thank you. It is okay to correct the speaker tonight. So, sir, calm down. So that's a big telescope, and what they did was they found this little asteroid, it's about 1 kilometer in diameter. Now, kilometer is only about 0.621371, very roughly speaking, of a mile. So about 2/3 of a mile. That's considered small by astronomers, but if it hit something on the Earth, we would know it. That could wipe out a city. Pretty big. This is the shortest orbit of any comet of any asteroid that's ever been found so far. Only 113 days to circle the sun. And the orbit is entirely within the Earth's orbit around the sun. Pretty cool. Gets pretty hot when it's close to the sun. Close. Helios was the sun god. Perihelion is the close point, because an orbit that's not a circle has a close point and a far point. That's an elliptical orbit. Gets to pretty close to about 900 degrees Fahrenheit, so it must be pretty hot, almost as hot as a New Jersey summer. Ooh. Now, because this asteroid also comes close to Venus, while Venus has strong gravity like the Earth, it may alter the orbit of the asteroid to change it to make it an outside orbit or just kick it right out of the solar system. This is going to happen again very soon in the year 2029. On April 13th, you are all going to see an asteroid that's 1,000 feet across, 3 football fields long, pass within the orbit of our geosynchronous satellites, about 20,000 miles. Unbelievably close. Not going to collide, we know for sure, so no panic. That's the asteroid Apophis. Don't miss it. I'll be advertising it. We've got only 8 years, so you'll be hearing me talk about that a lot. If you want to learn about what's up in the sky for yourselves, you can do that at csky, right? .org, csky. I'm going to concentrate on the astronomy part, so that would be the sky. And you want to click on Astronomy Reference Guide, and you come up with a whole confusing menu of things. But the thing to look for is the calendar, astronomical calendar. You can pick any year, and if you do that, you'll come up with a list of things. I dissected the list and put like things together. So this month, 2 moons, a new one and a full one. What is a new moon? It's the best time to look at the sky. September 7th, what's today's date? September 4th, thank you. So that means the moon is getting closer and closer to the sun. In the sky, is it really getting closer to the sun in space? No. The moon is 400 times smaller than the sun, but it's also 400 times closer to us. The sun is roughly, I'm rounding off now, you can correct me, 100 million miles away. The moon is 250,000 miles. 100 divided by a quarter is 400. 400 times smaller, 400 times closer. So that's why we have eclipses. This happens at universal time in England, 0:52 on the 7th, which means here, because we are behind England, right? We're later on in the day, earlier. They get the sunrise first. So if it's noon there, it's 4 hours earlier. Noon minus 4 is, right, 8 in the morning. So we're earlier. So what's 0 hour? What's midnight minus 4 hours? 8 o'clock at night. 8:52 is when it happens the day before for us. We also have a full moon on the 22nd, right? So it's going to be about a half month apart. The moon takes 29 and a half days to go through all its phases. It's not exactly 30, it's not 31, it's not 1/12 of a year. 23:54 universal time. I'll let the mathematicians in the audience figure that one out. The Native Americans called this the corn moon, good time of the year to harvest corn, also known as, you guessed it, harvest moon. I'm going to be moving probably in front of the screen and away from the screen. So if you can't see something that I'm talking about, you can either tell me to move, or you can just fall asleep and forget about it. Mercury, innermost of the major planets. There are now how many major planets? My very educated mother just served us 8. Just served us 9. And I'll make up the last one for Neptune. 9 nice burgers. What's the first one? What's the first planet? Mercury. If you want to see it, it's orbiting so close to the sun that it comes and goes very quickly. 88 days. To find it in the evening sky, great time of the year to do it is right now, this month. It's going to be east of the sun. At Jenny Jump, here at UACNJ observatories, south is that way behind you, which means that the sun, the moon, the planets, the stars, everything is moving east to west that way. So you want to look for Mercury low in the west, not here with all the trees, but at home, near the shore, somewhere where you can see beyond the trees and houses. 26 degrees up, 27 degrees. Your fist at arm's length is about 5 degrees, so about 5 or 6 of those. And that's how you can find Mercury. Best time to see it in the evening sky. Neptune, furthest of the major planets. My very educated mother just served us 9 nickels. 9
Nachos.
nachos. Woo!
Served us nachos.
This is a big planet. Doesn't look like much, even in the biggest telescopes in the world. Fuzzy blue disk. But it's a planet 5 times bigger than the Earth, made of gases. It's gigantic. So astronomers, now I'm going to throw a lot of scientific terms at you tonight. Don't expect you to remember all of them. But if you put the terms together, Neptune is one of the gas giants. Gas giant. Repeat after me. Gas giant. You got the first scientific term. Excellent. We'll let you go home. If you miss one, you'll have to stay. This is visible all night long because Neptune is at something called opposition. Lined up, Sun, Earth, outer planets, not only Neptune, but Jupiter and Saturn as well. And that's why they look so bright. And that's why when you look at Jupiter over your right shoulders, it looks bright. It's closest to Earth, or we should say Earth is closest to it. Astronomers measure distances in Earth-Sun distances. Earth is 1, Jupiter is 5, Neptune is, Uranus is, let's see, 19, Neptune is 30 times further away. The distance from Jupiter to us is 5 minus 4 is, 5 minus 1 is 4 astronomical units away. Each astronomical unit takes about 8 1/3 minutes for light to travel. So if the sun turned off this moment, we would have about another 8 minutes. When you look at that bright star, it's not a star, that's the planet Jupiter. Light is coming to us from a half hour in the past. That's how Jupiter used to look. Is it still there? We don't know. We'll find out in a half hour. So it's a good time to look for the planet Neptune. I'll show you where it is. Other events, September 22nd, when days and nights are equal on the Earth, equinox. Equa for equal, nox for night. Equal nights, equal days. The sun is directly over the equator. It's the first day of autumn, officially speaking. To see this, rather than me talk about it, or you look at a sky that's not necessarily ideal, like when it's cloudy or hazy, you can use something to simulate the sky, computer programs, apps. 2 are called Stellarium and Celestia. Stellarium is great for simulating a view from the Earth, looking at the sky, anywhere on the Earth, anywhere in time, past, present, future. And that's what we're going to use right now. I've downloaded Stellarium from stellarium.org. You can just go on their website, web.org, if you don't want to install anything. Let's take a look at Stellarium. And afterwards, if there's time, we could even fly through space with a simulator, Celestia. So let's take a look right now at something you could do at home. Well, a bit of a meteor shower there. We're facing north. Can you tell? So you just go outside, just like Stellarium. You go outside, you look low in the sky for the big letter N, right? No. Does the real sky have a letter N? Nope. So you've got to find your way by identifying some famous groups of stars. I don't recognize anything. Do you? Well, we can cheat a little bit. We can draw pictures in the sky with lines. I imagine lines when I look at stars. And you might be able to find 7 bright ones that form a kind of a dipper, or if you go to England, a plow, part of a creature with a big head, sharp claws, and a long tail. Ursa Major. literally bear big. And this is what? Big Dipper. And what's that? That's moving. What is that thing? You might see one of these occasionally. You can click on something in Stellarium and identify it. Yep, satellite. You'll often see some of the Starlink satellites that Elon Musk put up. They're fairly bright. If you see one, you can point it out. In Stellarium, I can click on a star and it will tell me its name. Merak and Dubi in the Big Dipper are the famous pointer stars that point, oh, that's okay, thanks, Kim, point to the Polaris, the North Star, about 5 times their distance apart. Thank you. Polaris, or North Star. Again, you can hold up your fist and go 5 fist lengths, and you'll come very close. You might even see it now over the roof of Jenny Jump's observatory, the main building here. North is that way. Well, there are other constellations that you can see all year round at night when it's dark, because they never rise or set. They just go in a big circle around the North Pole star, like this. And they are the Queen and King. See them? They look just like a king and queen. Don't see them? How about now? And between the two dippers, Draco stands for dragon. Alpha Draconis. Astronomers like to label things from bright to dim in the Greek alphabet. So the brightest star is Alpha, Alpha Draconis and Draco. The brightest star in Orion would be Alpha Orionis, or Rigel. The bright stars all have names. But this one, Thuban, used to be our pole star. That was where the Earth's North Pole used to point. Here's where it points now. What happened? Well, the Earth is spinning like a top, but it's also wobbling like a top. Did you know that? Can you feel it? No. If any of you have ever visited Switzerland, there's a clock that has this motion. It takes 24,772 years to go around once. Those Swiss, very clever. They must use a pretty big gear, a very slow one. Yep, that's called precession, and it changes where the Earth's North Pole points. Anything that spins has got a pole, and it points to somewhere in the sky. So these 5 constellations are going around the pole. They always spin around it. They don't rise or set. But if you look further over to the west, you will find the stars of spring and early summer disappearing. Arcturus, the bright orange star. In Boötes or Boötes, the herdsman. Looks just like a herdsman, right? See it? Oh, yeah. I don't know. Some of you are maybe a little tired. Maybe you're hallucinating. Some of you have come a long way. I appreciate that. Please be careful going back. If you start to see herdsmen on the road, please pull over. Right next to a herdsman, a crown. Look up high in the sky. You'll still see a crown corona. You'll still see the letter H. The letter, sort of an H for a famous hero of legend whose name starts with the letter H. Yep, Zeta Herculi, star in Hercules. Right between these 2 stars on the right of the keystone. Odd-shaped stone in the middle of an arch, keystone. Right down here, go down 1/3 of the way from this star. Down, right about there, you'll see a fuzzy blob. I like to call it the fuzzy blob in Hercules. It does have an official name. With a pair of binoculars, you can actually see that it's a fuzzy cloud. In a small telescope, you'll start to see stars. And in a large telescope like the Hubble Space Telescope, you'll find 500,000 stars in a big globe, shaped like a globe. It's something, a collection called a cluster. So it goes by that super scientific name. Take a guess. Globular cluster is correct. You win. What do you win? Let's see. You can go home. Yeah, yes, yay. Yeah, we are nothing if not efficient and cheap here at UACNJ. So this is the most famous and most easily observed globular cluster. There are thousands of these that orbit the Milky Way at a distance, our galaxy, in every direction. They are very old. They're among the first clusters of stars to form billions of years ago. Our Milky Way being about 10 billion years old, the universe being only 14, we live in a young universe, relatively young universe. The Earth only about 4.5 billion years old. There is a brighter globular cluster, Omega Centauri, but very far south and hard to see from New Jersey. Look how far I have to zoom out to see a constellation. You do need a telescope to see some of these things in detail. They're so tiny in the sky. Scientific term, tiny. If we look lower in the sky, close to the horizon, what's the horizon? This thing here. All right, the division between the trees and the sky, the ground and the sky, the houses, if you're not so lucky, like where I live, it's big houses blotting a large part of the sky, but you can still look straight up. Then you might find the scorpion and the teapot. Do you see them? Scorpius, sign of the zodiac. The heart star, bright red star, not in stellarium, which does not show colors very well, but the human eye can see that the heart of the scorpion, Antares, glows a bright reddish color. It's a giant red star, so big it would swallow the solar system out to the orbit of the planet Mars if it were where our sun is. Yep, there are giant stars, there are dwarf stars as small as a planet like Earth. And then we have an average star like the sun, which is only about 100 Earths across, average. Stars come in a variety of sizes. Can you imagine the scorpion, stinger on the end, the double star? The teapot-shaped group of stars, believe it or not, is not a teapot. That's what we amateur astronomers call it. I am an amateur astronomer. I've been talking to you, the public, who I love, for some 27 years for free. I do this for love, not money. Amateur astronomer. The amateur astronomers here are very dedicated. They've made up names like teapot, but this is a sign of the zodiac known as Sagittarius, the shooter of Sagitta, the arrow. Half man, half horse, holding a bow and arrow. Yep, something you see every day. Can you find it without the lines? If you can find the spout of the teapot, right above the spout comes the steam of the Milky Way galaxy. We can actually see our galaxy, a collection of some 1,000 billion stars. That's 1 trillion, a 1 followed by 12 zeros. It's a lot of stars. And you can see about 3,000 of them on a nice clear night, with the Milky Way going straight up across the sky and over to the other horizon. I don't know if you're going to see it tonight. I do see some clouds and haze, but it's worth a try when things get really dark. Bear with the sky. Hang out as late as you can, and you may see it. The steam of the Milky Way comes up from the spout, and right about there is a supermassive black hole at the center of our Milky Way galaxy. Supermassive black hole weighing millions of times the weight of our sun. Can you see it? Can you see where the arrow is? Why can't you see a black hole? Because it's... Right, thank you. But you guys are not easy to fool. But what you can see is where stars are being born. Right above the spout are 2 things called nebulae, plural for nebula, or you can call them nebulas, but the Latin way is to say nebulae, plural. Right there is a nebula where stars are forming, made of hydrogen gas glowing beautifully in a reddish color. Colors that are hard to see by the human eye, but can be seen on long exposure photographs. And running through the middle of this is dust that may one day form a planet like Earth, a dark lane of dust running down like a lagoon. This is the Lagoon Nebula. Also glowing a little bit in the light of bluish stars, hot young stars, hotter than the sun, burning their fuel so quickly that they burn out in a fraction of the sun's lifetime, perhaps 1/10 or 1/100th as long as the sun. The sun's been around 5 billion years. Hot blue stars like the one in the Trifid Nebula live only a few 100 million years at most. Can you see the 3 lobes? 1, 2, 3 in the Trifid, glowing red and blue. Blue starlight, red light of hydrogen gas. Someday this too will form a solar system, or perhaps several thousand. Trifid Nebula, Lagoon Nebula. One year here at Jenny Jump on a dark night, I looked in the south, right behind you, right about where those trees are, from a clear spot. And I saw a little patch, a fuzzy patch above the spout of the teapot. With my naked eye, I saw the Lagoon Nebula, a stellar birthplace. Repeat after me. Equipment we should all use. Naked eye. There's a bunch of shy people in the back. What was that? Thank you. Equipment we all have, we should all use. That's how I learned. I learned from star charts. Of the kind that we sell in our gift shop. Shameless advertisement. There are many objects like nebulas and star clusters that we can see if we look closely in the sky. A cluster of stars, a star cluster. These are called deep sky objects. Far away from us, generally thousands of light years, further than the closest stars, which are dozens of light years. Closer than other galaxies, which are millions of light years away. We can actually see one with the naked eye, believe it or not. You can see an object that's in the Guinness Book of World Records. If you go up over towards the east, you pass by the Bikini Top, or the Bikini Bottom, if you use this star. This is my constellation, my sun sign, Capricornus. What's Capricornus? Goat. It's a sea goat. You know, something you see when you go to the beach. Half fish, half goat. Yeah, it's like, the mermaids, the sea goat, the sea monster. Very common. Amongst the stars of Capricornus this month, you can still see bright stars that move. Bright stars that move. Saturn, Jupiter, those are not stars, those are planets, right? They move because they're moving around the sun in orbit, so they seem to go against the other stars, to move amongst them. That's why the ancient Greeks called them planetides, wanderers, from where we get the name planet. Look for Jupiter and Saturn. To the left of Jupiter and Saturn in Aquarius, you may also find a distant planet, Neptune, which is moving through these stars, and I cannot identify it unless I actually, search for it. So let's do that. And there it is. It actually finds it for you amongst the stars of Aquarius and Pisces, the fishes. Very low in the sky. Look how tiny Neptune is, how many times I have to zoom in to magnify it enough just to see it. Neptune has a giant moon, Triton. It has many moons, but that's one of the largest. It may be a captured dwarf planet, almost the size of Pluto, the brightest of the dwarf planets. Neptune shows a blue featureless disk even in the world's largest telescopes. So we've got 3 giant planets, Saturn, Jupiter, Neptune, all lining up in a straight line. This is a line that we can draw out into space. If we draw the Earth's orbit out into space, we would find that the sun, moon, and planets all follow this straight line that passes through famous constellations or signs, the signs of the zodiac. Currently, there are not 12, but 13, because the Earth, when it wobbled and moved from Thuban to Polaris for the North Star, it also upset the ecliptic path, the Earth's orbit, drawn out into space. So now we have Ophiuchus, the serpent carrier, who's the 13th sign of the zodiac. He lies above the scorpion. And he almost, well, does he really look like a guy holding serpents? I don't know. Without the picture, without the lines, I can't find him at all. There he is, Ophiuchus, holding the head, tail of the serpent. We've looked at an awful lot. I probably confused a lot of you. We're going to have a quick review. But before we go, if you have, what we've done is we looked from west to high and then down low and back up again. If you look over high one last time, you'll find bright stars overhead, 3 bright ones. In fact, I can see them now. Just about directly overhead is Vega in Lyra the harp. Lyra the harp. An ancient harp. Looks like this. Cygnus the swan. Almost looks like a swan. Aquila the eagle. Each has a bright star. 2 of the bright stars were in science fiction movies. Vega in Contact, a novel by Carl Sagan. Altair in a movie, Forbidden Planet, from 1956, old but good. And Deneb is jealous because it wasn't in any movie. Sorry, Deneb, the tail of the swan. I'll leave you with one of the most beautiful stars in the sky, the head of the swan. Ask one of our amateur astronomers tonight, when you're either looking through a telescope or looking at a projection. Don't know if it's safe to actually look through telescopes yet, but we may be projecting an image on the side of the building. Look for alberio, or ask someone to show you alberio in the head of the swan. This is a beautiful double star, 2 stars that orbit each other. One of them has a cyan or blue-green color, the other golden, kind of like our sun. Not well seen in stellari. Oh, there you go. Okay. Hard to believe how beautiful this star is. Right nearby, you'll find the arrowhead shot by the arrow shooter. There it is, see Sagitta? Looks just like an arrow, right? No? Yes? No? How about a little asterism hanging in your coat closet? What is it? Coat hanger. It is not a constellation. Ask someone to show it to you. It, like the Big Dipper, is an asterism. Star, picture, asterism. Not a constellation. There are beautiful other deep sky objects to see. One of the amateur astronomers here, using their telescopes, can show you that on a nice clear night. Perhaps someday when we go back to safe enough to look through telescopes, we can all line up to do so. I hope you'll come back for more talks. We do them every Saturday night, April through October. Otherwise, it's too dark, but I'll be delivering my What's Up in the Sky talks every month, right through the winter, virtually. I hope you'll come visit. That's Stellarium. I'm going to wrap things up by concluding with some history and a review. Oh, no, don't cry. It's okay. It goes by quick. All right, so let's pick one time to look at the sky, shall we? So we always know we're going to see things the same way. I'm going to pick 9:15 at night because it's when your astronomy speakers at UACNJ stop talking. You can concentrate on the sky yourself. Don't listen to the experts. If you don't believe us, go out, find the stuff for yourselves. Use one of the star maps you can buy very cheaply, shameless advertisement, in our gift shop. Kim will show you that later if you want to visit. Looking to the north, you'll see Big and Little Dippers, the dragon, the king, the queen. Perseus, the hero of legend. Looking south high, the summer grouping of 3 bright stars that form a triangle. What would you call this triangle you see in the summer sky? Take a guess. One of you is cheating. You're looking at a book, aren't you? Yeah. You're looking at your tablet. Yeah. Your phone, your phablet. Your phablet? Okay. Yeah, that's the summer triangle. Check it out. See if you can find it yourself. When you look here, you're looking into the past 25 years. When you look here, 16 years. When you look here, 1,400 years in the past. That's how far away these stars are that it took like that long. Look for Hercules, the hero, next to the bright star Vega. Look in Hercules for the globular cluster M13, M number 13. If you look low in the south, you can find Sagittarius, the arrow shooter, or otherwise known by amateur astronomers as the Teapot. Correct. You win, sir. You win a free trip to the bathroom. No. You'll find the moon in the middle of the month on the 15th. The moon gets in the way because it is bright. Yep, but you will see planets even when the moon's out. Saturn, Jupiter, Neptune, you need a telescope. Neptune had to be discovered. Find the stuff for yourself, it's fun. And then finally, coming up in the east, I guess higher on next month, we'll see Pegasus, the flying horse. 2 stars over and 2 stars up give us in the Andromeda Galaxy, which I forgot to show you in Stellarium. Shame on me. Would you like to see the Andromeda Galaxy? Do we have time? Yeah, we do. All right, let's do that. Stellarium is a free program in version 0.21. Many years ago, I started all the way back with version 0.14. When are they going to get to version 1.0?
When it finally costs money.
Yeah, well, this is a free product, and they work on it for free. So I'm going to look for the letter E for East. You all run out there tomorrow night. No, it's going to rain. Tuesday is going to be nice. Go out Tuesday night, look for the letter E. Are you going to see it? No. Good, you guys are pretty sharp. Can't fool you. You're going to look high for a giant square. It's oh yeah, you guessed it. Astronomers call it the Great Square. And it looks really big. In fact, to see Pegasus, the flying horse, you have to turn your head from side to side. It's that big to see the whole constellation. If you go over to the left, you'll see that part of the constellation is Andromeda, the princess. 2 stars over and 2 up between a letter Y is a fuzzy blob 3 times bigger than the full moon. The light from this blob left 2.5 million years ago. It's the Andromeda Galaxy, nearest galaxy to us, a little bigger than our own, with satellite galaxies. Here's 2. There's one right there. Has its own M number, M110. Andromeda itself is M31 in Messier's catalog. You can see it in a small telescope. Looks something like that. You can see it in binoculars. Looks something like that. You're looking at it in the past, 2.5 million years ago. Check it out. And what do you need to see it? The what? Thank you, shy people in the back. I know standing up is tiring. You're entitled to be shy. That's okay. All right, so that's Stellarium. And one last thing. You're not going to find out what's up in the... Oh, I forgot. Neptune, right there between the fish and the water carrier. Saturn, Jupiter, Neptune, the planets always line up in a straight line because the solar system is pretty much flat, except for Mercury, tilted a little, Pluto, tilted a lot, and comets are all over the place. If you go outside every night the same time, you're going to notice a change from month to month. That's why I'm going to ask you to come back to see what's up in the next month. What's up in the October sky. If you face south, 9:15, go out south. Look there. You'll see the full moon. Well, a moon that's nearly full. You'll see Sagittarius. Watch what happens to Jupiter, Saturn, and the moon. October. Did you see that? Let's do it again. 9 o'clock, 9:15, September, October. September, October. You dizzy yet? The sky changes by 1/12 of an angle of the whole sky. 360 over 12 is 30 degrees. So you're seeing a different sky every month. You're looking in a different direction. And that's why I asked you to come back, see what's up in the sky April through October. My name is Lonny. I'm here every first Saturday in the month. Through those months, be delivering the talk virtually the other months. Before we go, a little history. 175 years ago, in this month, John Couch Adams, I'm looking a little like him, losing my hair just like him. In 1843, he concluded that there was some planet pulling on the planet Uranus, which was late and early in the predictions of where to find it in the sky. What was pulling on Uranus? An unseen planet that you could calculate through mathematics. Leverrier, French astronomer, did this in 1845, and then 23rd of December, then September the next year, 23rd of September this month, he found, his calculations found the planet Neptune close to where he predicted. Astronomers found it. And that was credited to two astronomers, Adams and Leverrier, who independently found the same thing, the location of Neptune. It's like the guys who never get credit. You ever hear of the Doppler effect? When something goes by you very fast, the sound will shift. Yeah, that's a Doppler effect. Well, poor Fitzhugh figured it out too. So it's actually really known as the Doppler-Fitzhugh effect. But does Fitzhugh get credit? No, darn it. Little homework for you. To find us on the web, repeat after me. UACNJ. UACNJ. United Astronomy Clubs of New Jersey. Umbrella organization for all kinds of astronomical societies in the Garden State. Magazines, Sky and Telescope Astronomy, they still have print versions. You can get them online. Parts of them are free, large parts of them. So go online, check them out. Check out Stellarium and Celestia on the web, or you can get app versions for your phones, your phablets, if you have a big phone, or if you have a flexible phone. Coming soon, I wrote this into my science fiction novel, a phlablet, flexible tablet. I've written a book that's on my website, astronomyinmotion.com. Uses, check it out, yeah, interactive 3D models of the planets that you work with your fingers or any pointing device. Virtual reality planets available everywhere. And I belong to the International Association of Astronomical Artists. Thank you very much. You've been a grand audience.
Thank you, Lonny.
Thank you.
All right. Hello? Hello?
We have a few reminders before you get up. Please wait just a moment. We have some announcements from Kim, and I'm going to ask you to just be careful when you get up, and please visit us again. Please see me again. Thank you very much. I love you all.
All right. Thank you, Lonny. Thank you, everyone, for coming out. All right. So, like Lonny said, a couple things. Face coverings are optional. I wear mine just because I have to go home to a couple of at-risk people, and I like to keep them safe. But we are following CDC guidelines. Like I said before, we are a nonprofit organization. Everything you see here has been donated or bought with money donated. And our program keeps running. Our lights stay on from those donations, from the sales from our sales desk, and we appreciate it all greatly. You can... my train of thought completely derailed.
Oh,
There were no survivors just then. So, on to the next thing. I noticed a couple of you did roll in in the middle of our presentation. So, a couple of reminders. If you need to use the bathroom, we have the porta potty to my right, your left. We do have the little gift shop over to my left, your right. I am the one who runs the gift shop. So after we do the Q&A session, I'll be heading back over there. And at that point, I'll be able to help you guys with that. We have been streaming these programs online on our YouTube channel. So I have been monitoring chat all during the presentation. So we're... I thought I heard someone yell something, and I didn't quite catch that. But, so what we're going to do now is a little bit of a Q&A session. Since there are a couple questions online, I'll start out with one here, and then I will grab one from you guys here live. I just ask that you wait till I bring you the microphone. That way, the audience at home can also hear what you are saying. Because chances are, if you have a question, they also have that same question, but might be too shy to ask it. So, with that, our first question is, do you think we will ever create new constellations, or is that just a thing that there is not going to happen?
Well, that's a very good question. Do you think we'll ever create new constellations? There are, back in 1930, long ago, even I was not born then, the International Astronomical Union settled on the same number of constellations, standardized, as there are keys on a piano. So if there are any piano players in the audience, you can shout out how many keys. Yep, 88 constellations. They are not going to make new ones, but in other cultures around the world, they're very different from the classic Greek mythology that we use currently. The IAU officially recognized the Greek version, but other cultures use different ones. Great question. So no, probably no new constellations.
That being said, if we were to colonize another planet or something, chances are we might see some slightly different organization of things. At that point, I would imagine people would start coming up with more for those very remote locations.
Sure, if you go to another star far away from the sun, the sky is going to look completely different.
All right. So, with that, we're going to take a question from our audience here. So I'm just going to ask that if you have a question, raise your hand and kind of wave it about, because I have trouble seeing in the dark. Anyone?
So you guys know everything about the sky now, right?
Yeah. Oh,
wow, great. Confidence, that's what I like. Maybe I should ask you questions. What's that bright, what are those two bright things up there over the trees? One is less bright than the other, and one's closer to us.
I saw a question over here.
Like, should I give you a hint? They're made of gas and they're really big.
Hey, Lonny, we got a question.
Oh, we do have a question.
I don't know if you mentioned this, but black holes are ravenous beasts, aren't they? If that's the case, then the black hole at the center of our galaxy, is it actually swallowing any interstellar matter, or?
Yeah, that's a very good question. What is the black hole at the center of our galaxy doing? What's it swallowing up? Well, for the first time in the last 10 years, astronomers have been watching an entire star system fall into that thing and give off X radiation. That's how we detect it. Gas, dust, and stars are falling into the black hole in the center of our galaxy. But we're in no danger because we are some 30,000 light years away. There's no danger we'll ever fall in. More danger that we'll fall into the endless black hole of politics.
Wow.
Good question.
Way to go to a very dark place there.
So what's that bright thing up there, and what's the lesser bright thing to its right? They're planets. Remember which ones? That's correct. Correct.
Right. So I have another question from our online audience.
Okay.
What happens after a star goes supernova or forms a nebula? would that material reform into a new star-planet combo, or will that just become space debris?
Oh, that's a really good question. What happens after a star goes supernova, or was that also nova?
Or like forms a nebula?
Oh,
So
a nebula. Yeah, now, yeah, that's right. A supernova could form a nebula. It's the destruction of the star, a star that's much more massive than the sun. It gives off gas and dust, and that gas can glow for a while after. So that's why we see an expanding cloud. That can last for, well, millions of years till it wears out. We can actually see the remnants of one that blew up in the year 1054 AD. It's now called the Crab Nebula because it has these tendrils running through it that looks like crab legs. Very dramatic. It's found in Taurus the bull, sign of the zodiac you see in the winter. So there are supernova remnants all over the sky. One of them is near Cygnus. Good question.
All right. I know we had another question over here. Oh.
Is there going to be a solar flare?
Is the question, is there going to be a solar flare? We do have those every so often. There was a major sunspot and flare recently you might have heard about. Solar flares that are very intense are so strong that when the particles reach us days later, it takes a while, they can interfere with radio communication and even knock out telephone lines. A major flare knocked out telegraph lines at the turn of the century. Another one would do much more serious damage to our current network of wires, of telephone lines. So it would be a good idea for us to harden those against such events. But will we do it? Probably not. Good question.
All right. I just put out a last call for adding questions online. Do we have another question here from our live audience? Oh,
Yeah,
thank
in the
you.
back.
Yeah, like I said, I have a slight bit of trouble seeing in the dark, so thank you for... All right.
What are wormholes and like how are they formed and how do they work?
Whoa, that's a lot of questions right there. What are wormholes and how do they work? All right, so the brief description, if you reduce the question to something we can visualize, we cannot visualize a four-dimensional wormhole because we are beings who see in 2 dimensions and put those 2-dimensional pictures together in our brains to make a 3-dimensional object in our minds. We see in 2 dimensions. That's what happens on our eyes. So let's say you have 2-dimensional creatures who live on a 2-dimensional surface, a sphere. They don't know that they're on a sphere. They think that they're on a flat surface that goes on forever. And if they went far enough, they'd come back to where they started. But it would take too long to do that. A wormhole would be if you could poke your finger into a flexible surface, a sphere made out of jello, right, on 2 sides, and bring those contact points together. You would have a 2-dimensional pathway alternately different from the surface in 3 dimensions. Now, if the universe we live in has 4 large dimensions, then perhaps there are 3-dimensional pathways that are shorter between stars. I actually wrote about this in my science fiction story. That's how the alien arrives at Earth almost instantly, through a wormhole. It's a distortion in the medium that Einstein called space-time, because space and time are not independent. They're intimately linked together. When you pass through a wormhole, you travel through time as well as space. You pass through almost instantaneously because time has stopped in a wormhole. Isn't that bizarre? I ask you. There's no more bizarre thing in the universe than a wormhole, but have we found any yet? No. We have found black holes which are not the same as wormholes. They are kind of like poking your finger in the jello, but not going anywhere. I hope that helps. You're welcome.
All right. There was another question over here.
You know, we have had past speakers talk about black holes and other bizarre objects in the universe. So you might want to come back for another lecture on a Saturday.
How are stars formed?
I'm sorry,
How were the stars formed?
how were the stars formed? Originally, the Milky Way was a huge collection of gas and dust. Even the smallest knot, the smallest concentration, would have a higher pull of gravity than anything else. Anything that has mass in the universe has a pull of gravity. It creates this attraction. And so objects accumulated over vast amounts of time to form big masses. Actually, in our solar system, it can take only a few tens or hundreds of millions of years, which is actually not long compared to the billions of years that Earth has been around. Those objects collide, form bigger and bigger objects. And all of the planets, we believe, were formed in this way. How do we know that it really happens this way? We can do computer simulations, but more importantly, we can see it happen around other stars. For the first time, we've seen pictures of other planets forming as knots in circumstellar gas rings around stars. It's amazing. We are growing up in a time that I could not have imagined when I was a kid. Because when I was a kid, we didn't know what any moon looked like except our moon. We didn't know if other stars had planets. And now we can see them. Thank you. Good question.
Yeah.
What do you think will be the most interesting thing we'll see with the James Webb Telescope?
What do I think will be the most interesting thing we'll see with the James Webb Telescope? I think there's going to be several things. It's tuned to the infrared. So the most fascinating thing I think we could possibly find would be a Dyson sphere. Now, a Dyson sphere is not a natural object. A sufficiently advanced civilization may be able to build structures around their star that would almost completely surround the entire star to capture its energy. Bizarre notion made up by the scientist Freeman Dyson, but it could actually happen. If a civilization could build with nanotechnology thin shells around the star, then what would happen is it could collect most of the energy. Sun would heat up the Dyson sphere, it would glow in infrared, and we could detect that. It's dim infrared sources. I'm hoping we can detect more objects like Oumuamua, bizarre asteroids that come in from outside the solar system, pass close to the sun and zip out again. Maybe artificial objects, a space probe from another alien civilization that might do the same. We thought Oumuamua might be like that, but it probably wasn't. That telescope should be able to look back further in time to the very beginnings of when light was released from the Big Bang, 380 million years after the birth of the universe. So just like the Hubble found things that we never expected, I think the James Webb will do the same. Hard to say. Maybe it'll find more dwarf planets. It'll find a lot, I'm sure. Whatever it is, it's going to be a surprise. Maybe we'll name one of the dwarf planets Surprise.
For a minute there, I thought we were talking about the vacuum brand, Dyson Sphere. And for that, I only need one of my sister's pet dog. He detects that thing right away. You turn that on. Nope. I know the vacuum's going. Right. Actually, one of our questions here actually spawned a question online. Speaking of birthing new stars and such, is it possible to create our own, like a new star, in a lab setting? And if so, what would it take?
You dropped out a little bit there, Kim. Can you repeat the question, please?
Speaking of birthing new stars and such, is it possible to create a new star, like in a lab setting?
Oh.
And what would it take to do so?
Actually, that's a very good question, because just a few days ago, scientists, for the first time, they were trying to create nuclear fusion, where one element turns to another. Just like the ancient alchemists tried to turn lead to gold, physicists almost succeeded in turning hydrogen into helium. They reached a point where putting in energy, they got 70% back out. Not 100% yet. There's still a long way to go before they get more out than they put in. But that's the most ever so far. That's a fusion experiment that uses lasers. So That's how you would create a star. You would fuse the hydrogen in a small container, a small amount. It was really tiny, like the head of a pin, and make helium out of it. In one of Arthur C. Clarke's science fiction novels, the aliens do this. They fuse the atoms in Jupiter and turn Jupiter into a sun so that it warms the moon Europa and gives Europa a chance to have life. Europa is a moon covered with ice with an ocean, a warm ocean inside. We think there may be not just microbial life, but advanced life inside this moon of Jupiter. We may find out within our lifetimes. In fact, there is a mission planned to go to Europa in the 2020s or early 2030s. We may find out yet if advanced life like cuttlefish or shrimp or tube worms evolved on another planet than Earth. Stay tuned. It's going to take a few years. Good question.
All right. Were there any last questions from our audience here? Oh,
I think you're all anxious to go see the real thing. So we'll be out there with you looking through the telescopes. Oh, well, thank you very much. Thank you. You've been a good audience.
hey, Lonnie, we have a question.
Oh,
Lonnie,
question.
we got one more.
A while ago I saw, like, around the moon, there was, like, this rainbow halo. Do you know what that might have been? Or, like, what that, like, thing is?
Yeah, earlier today, we saw, coming to Jenny Jump, we saw cirrus clouds in the sky. They're very wispy. You ever see that? They're more seen in winter. They're made of very fine ice crystals. Ice crystals act like tiny miniature prisms, and they break up the light, the white light of the sun, into all the colors of the rainbow. And so you see refractions, bent light, around the moon at approximately 60 degrees or other angles, forming a halo around the moon. That's light being bent and reflected by the little tiny ice crystals. There are different kinds of halos. The most impressive I've ever seen is 60 degrees across, which is how big Saturn looks like from some of its inner moons. It's just an enormous circle. Very good question. There are all kinds of beautiful halos. If you go to, there's a website that follows the sky. Check out Sea Sky and what is it called? I think it's Sky Picture of the Day. I'll have to look that up. You can always email me, lonnybuinis@gmail.com, and I will find it. Good question.
All right. Were there any last minute questions? Oh, I don't see any.
You've been a very patient audience.
Thank everyone for coming out. Like Matt started saying in our intro, do check us out on our website, UACNJ.org. We also have a Facebook, a Twitter, Instagram. Like I said, we do stream these on YouTube live, but you can also go back and check out our past broadcasts there from when we started doing this during the pandemic. We also have a Discord server. The links should be on our website. That's where you can get together and chat with other astronomy people. We are just getting the Discord server kind of started, so it's not very... We also have a Patreon now that I forgot to mention. If you want to do a small donation where it's a monthly recurring fee, you can hit us up there. And like I said, that goes to helping us out, keep offering these public programs. So, also one more thing to note, when we leave here, please use our headlights because it hurts getting run over and we like avoiding that. And with that, thank you, Lonnie. Thank you, guys, and have a good night.